on next in our systems objective is going to be solving a value mixture problem using a system of linear equations. Okay. So how this one's going to work, you kind of want to read over the problem, just make sure you get the gist of it. So the Campbell family and the Martin family each used their sprinklers last summer. Campbell family, their sprinkler was used for 15 hours. Martin's family sprinkler was used for 30 hours. Their combined total output was 975 liters of water. What was the water output rate for each sprinkler if their sum of the two rates was 45? So a little hint in here, when you're looking to try to solve these problems, you want to figure out what your x and y are going to be, right? What are your variables? What are you trying to solve for? Well, it's usually in that last sentence. What was the water output rate for each sprinkler? That's what we're trying to figure out. So my x and y will be the rate for each sprinkler, if that makes any sense. Okay, so let's see if we can kind of diagnose this problem a bit. Okay, so if x, we'll just call the Campbell's rate, that's their rate, and y, and we'll do y is the Martin rate. So you got to know what you're looking for first. We're looking for rates. So let's use some words here. All right, it says the Campbell family sprinkler was used for 15 hours. Okay, and then the Martin family was used for 15 hours, or 30 hours, and their combined total output was 975. Well, we can make some sense of that. If you think about it, Campbell, which was red, okay, used it for 15 hours. So 15 hours times their rate, right, however much water they're putting out per hour, will give us their total usage. And then if you add together the Martin's rate, which is 30 liters, or 30 hours at whatever their rate is, which I don't know, okay, y, will give me a total output of that 975. So 975. Okay, so that's one equation. One down, one to go. You have to have two equations for this problem. Okay, so your second equation, you might want to just go back to this last line. It says if the sum of the two rates was 45 liters per hour. So the sum of the two rates, so Campbell rate plus Martin rate would be 45. So x plus y would give you 45, because that's their rates combined together. So if those two equations make sense, like that, you did the hard part. Now comes the easy part, solving this. You have lots of ways you could solve this, but my personal favorite would be just to graph it. Okay, you can use substitution, elimination, or you can go to Desmos, type it in, 15x plus 30y equals 97, or 975. Okay, so that's one equation. Here's the other equation, x plus y equals 45. Here's your other equation. Let's take a little zoom out on this thing, see if we can figure out where they cross. So it might be way up there because, 975 kind of brings it up a little bit higher. All right, let's see. It looks like, bam, it's right there. So my x value is 25 and my y value is 20. Does that make sense? Yeah, 20 plus 25 is 45. That makes sense, and the other equation will work too. So what I'm going to do is I'm going to take that 20 and 25, and that's going to be my x and y. So if I'm looking at my problem, right, the x value would be the Campbell rate, right, at 25. Okay. And then the Martin's rate, which is my y value, that's what I chose to be, is just going to be 20. Okay, so there you go. Yeah, and you're done. That's all you had to do. So you just got to pull the information out of the problem, stick it in Desmos, see where they cross, and you're done. Okay? Piece of cake. Good luck on that. All right.